Tonight we're doing something different. We're just starting off immediately with a lecture by David Dana-Bashian, right? And it's entitled 16 Nearly Impossible Issues for Evolutionists to Answer. So a little background on David is that he has a master's in mathematics and a bachelor's in chemistry. And in his lecture, he will be describing 16 issues in cosmology, astronomy, physics, chemistry, biochemistry, biology, and information science that are nearly impossible for evolutionists to give any plausible scenarios. In his talk, he will repeatedly show how evolutionists' attempts to answer these issues fall woefully short of fulfilling basic, well-known scientific laws, the very same laws that they claim to uphold. So, I'm going to hand over the mic to our speaker.
Thank you, Emma. Tonight's topic is 16 nearly impossible issues for evolutionists to answer. There's my email address if you care to use it later. Main objective is to sketch 16 issues that are mostly scientific. And the claim I'm making is that the evolutionists' responses fall short. First, some groundwork. When I was taking a History of American Education course many years ago, I learned something once that frankly had nothing to do with education, but did have to do with the four philosophical schools of thought. I want you to keep these schools of thought in mind when answering the question, how do we know something is true? The four are absolutism, which means somebody said so; empiricism, which means somebody tested it; pragmatism, which means somebody discovered something worse; and existentialism, which means somebody found that something occurred. The preferred choice for this talk is empiricism. Maybe you have seen this quotation before. It comes from a Warner Brothers cartoon called Here We Go, which was put out in 1949 and released in 1951. And in this cartoon, Columbus was debating Ferdinand and Isabella as to whether or not the Earth is flat or round. She's a round, she's a flat, and so forth and so on like that. That's oftentimes what happens when we come to a subject. We'll have people on either side of the issue. Maybe, maybe not ever come to a conclusion. In the case of Columbus, he eventually did win, but not before about 9 weeks later after he voyaged. Empiricism I call the dispassionate interchange. That is, we aren't bringing politics into it. We're not bringing emotionalism, vitriolic comments. This is objective stuff. And you can see some of the things that go along with that dispassionate interchange. You might be familiar with most of those if you had any schooling. I want to focus on the bottom where it says that we only have probabilities that range between just slightly above 0% and just slightly below 100%. It might be high, it might be low, it might be in between. But I also like to comment that we would prefer to have those things that have the higher probability than the lower. Because if we favor the low probability, we're saying we believe in miracles over science. And this is typically what happens with the evolutionists. They'll be actually going from the impossible to the possible, to the plausible, to the probable, to the certain, without having more or less any justifications for any of those steps. Here's another quote that you might recognize from The Blind Man and the Elephant from John Godfrey Sachs. You might have thought it would have been Rudyard Kipling, but it really wasn't. I want to focus on the last two lines. Though each was partly in the right and all were in the wrong. We each come to the table with our own perspectives. But they're only part of the story. Everybody has a little bit more to contribute, and the whole picture emerges as a result of many such perspectives. One general principle I'd like to mention is that verified scientific laws don't displace other verified scientific laws. When I pick up my news in the morning and I read about a great discovery out there in outer space and how it supposedly satisfies this and thus and so newfangled discovery, how many times does this news article ever get back to the old laws, the ones that we knew before, and see whether or not it matched them? I don't find too many places, frankly. And Stephen Wolfram found this out the hard way. He's the guy who runs Wolfram Research, from which the software product Mathematica arises. And he found out that 3 of his skeptical colleagues said that the new science better agree with the old science. And I was there to see this talk, by the way. It occurred, by the way, the same day as the Columbia disaster. At Christmas time, you might see the miracle on 34th Street. And the Santa Claus character has a number of interesting quotes. For example, you've heard of the French nation, the British nation. Well, this is the imagination. I'm sure that would suit Disney well. That's all these things ever turn out to be, in many cases, mathematical models without real results to back them up. Also, the Santa Claus character said, if I may replace one of those words, I have great respect for science and great contempt for amateurs, sometimes said to be meddling amateurs who go about practicing it. For those of you who have passed through high school, you might have run into the terms extrapolation and interpolation. Can anybody tell me what either of those 2 terms means? Interpolation or extrapolation? Can anybody tell me what either of them means? Anybody at all?
Extrapolation, you project a trend into the future from the past.
Okay, and you were going to say? Much the same? How about interpolation? Yes?
I was going to talk about extrapolation. You're taking facts and you're reaching a conclusion from taking the facts. No?
No, I wouldn't go with that. As being a definition, I'd say that's just making a conclusion. Anybody want to go for interpolation by any chance?
Looking at point between 2 known points.
Points between known points, that's right. That's the basic criterion of interpolation. We're trying to fill in an interval, curve or straight line or whatever. Whereas extrapolation is we're trying to extend beyond the boundary of the data points. We're not filling in things, we're going beyond where those points are. Notice these quotes. Extrapolation is similar to interpolation, which produces estimates between known observations, but is subject to greater uncertainty and a higher risk of producing meaningless results. Yeah, that's what happens when you go back into the unobservable, unrepeatable past. In the courtroom, we call this circumstantial evidence. And the probability of mischief is much higher for extrapolation. I want to say something about the topic of evolution in general, although I'm really addressing evolutionists. Evolution can mean a number of different things besides biological. I've been fighting it out with some people on the internet lately who seem to think that it's only biological, and anybody who says otherwise can't possibly have a shred of credible statements to make. This is just not so. Evolutionists see a stake in all these other issues, as you can see them listed. In fact, they have to have an infinitesimal to man scenario, or else it's really not a whole picture for them. This is a copy of my physical chemistry textbook when I was a graduate student. And in the first few pages of that textbook, which you see on the left of the 2 pictures, are the 3 laws of thermodynamics plus a 0th law. The 3 laws are as follows. The first law is that the universe's mass energy is constant. It neither increases nor decreases. Or, as is said in that book, you can't win, the best you can do is break even. The second law is that entropy, the measure of disorder, increases unabatedly. Or, as somebody said, you can only break even at absolute 0. And notice, by the way, the second quote, entropy is time 0, from Sir Arthur Eddington in 1922, comes from the book on the right, Physical Chemistry by Gordon Barrow, the one with the blue cover, in Chapter 8, Section 2. He says it leads to interesting philosophical discussions. I should say so. The third law is that absolute 0 is unattainable. In other words, you can't reach absolute 0. Let's review those. You can't win, the best you can do is break even. You can only break even at absolute 0. You can't reach absolute 0. And there's a 0th law, you must play the game. Therefore, the conclusion from thermodynamics, if we had nothing else to go on, is you must lose. And there is the copy of Gordon Barrow's Physical Chemistry textbook. Let me present now 16 issues for which the evolutionists have either no answer or an implausible or insufficient answer. Number 1, why does anything exist? Number 2, did the universe always exist? 3, did the universe cause itself to exist? 4, how can the universe avoid heat death? 5, how can any material travel faster than the speed of light? 6, what is the origin, transportation, and distribution of carbon? 7, how do any stars exist? 8, how do moons form? 9, what is the ongoing source of long-term comets? 10, how do any elements heavier than iron exist? 11, how do peptide bonds exist? 12, how do proteins have only L, liber rotatory or left-handed amino acids? 13, what turned non-life into life? 14, how does metamorphosis occur? 15, how do major morphological changes occur? 16, what creates information from gibberish? I'll go over each one of them. You may have your favorites. I have mine. We'll see. Issue 1, why does anything exist? If nothing does exist, we have no space, we have no material, no people, no meaning, nothing. From nothing, nothing comes. I would propose to you that the answers to questions like this, if they exist, start with Roget's pocket thesaurus, which you can see to the side. Roget's pocket thesaurus is hardly just a treasury of synonyms and antonyms. From its 1,000 categories, we can see the structure of language itself. And since category number 1 is existence, we might expect that at the other end of the thesaurus we would find possible causes of existence. And I suppose you might imagine what I would think that cause to be. There's a bigger picture of the thesaurus. I have these books, by the way, back here if you care to see them, any of them. Let me go into a little bit more detail now. Not only do the evolutionists have no real answer for why does anything exist, but they also don't have any answer for why this particular amount of mass or material exists. It's been estimated that the universe contains about 10 to the 80th atoms. Why not 10 to the 79th? Why not 10 to the 81st? And why this particular distribution in the universe or on the Earth? The matter of distribution will come up over and over and over again throughout this talk. Things are not scattered uniformly where they could not be economically mined. Instead, they appear as clumps. Why would that be? Lately, also, there is a subject matter that's come to the forefront called quantum fluctuations. Does anybody have any idea what quantum fluctuations refers to? I'm just taking a guess. Somebody might. Anybody at all? No? Okay. Quantum fluctuations, as is widely held to the public, is that nothing at all, an absolute nothing, can produce a particle and an antiparticle, and that they can come back together. And by repeating this process, we can create a universe and an anti-universe. Is that even possible? What happens when a particle and an antiparticle come together? Can anybody tell me that? Yes?
Turn into energy.
An engine?
Energy.
That's correct. They annihilate each other and produce energy. So, if that process were true, that absolute nothing could turn into energy, what would happen then? We would be able to produce unlimited amounts of energy out of nothing. What law of thermodynamics does that violate? The first law, that's correct. We already have a violation then of the first law, if that's what's being held. Instead, what's really being posited is that an already existing energy field produces the particle and the antiparticle, and that they can come back together and form the energy again. Of course, the evolutionist has a problem. Where does the energy field come from, since it already must exist? Issue 2. Did the universe always exist? No. They wouldn't say that, but I would. Otherwise, we wouldn't be here. Everything would have already dissipated. Why? According to what law of thermodynamics would it have already dissipated? The second law, that's correct. Now, this leads to a problem. Everything would have already dissipated. So therefore, we have a question. Is the universe open or closed? If it's open, then that could allow outside entities, for example, God, into the picture. On the other hand, if it's closed, then there's no escape from the thermodynamics. Things will continually wind down. Issue 3, did the universe cause itself to exist? I've had people answer the second question, did the universe always exist, in the affirmative. And then when I show them that it couldn't have always existed, that when they come to this question, did the universe cause itself to exist, they'll answer this question in the affirmative, even though that would contradict their answer to the second question. No. Otherwise, the universe would have had to have existed before it existed to cause itself to exist. Or the universe would have had to exist and not exist at the same time and in the same context. It's a logical contradiction either way. This is a little busy chart here. I want to make our first application in total. I want to use those 3 issues to form a cosmological argument. Does anybody know what a cosmological argument is, by the way? Anybody? Huh? Thought I heard something. Okay. Cosmological argument is an argument to show that something outside the universe is the cause of that universe. Let's start with issue 1. By application, does the universe exist? Yes. If it doesn't, we have some hospitals down the road with little white coats, which you can visit and be trapped inside if you like. Issue 2, did the universe always exist? We already said no. Issue 3, did the universe cause itself to exist? We already said no. Therefore, I have just ruled out every material cause of the universe, because every other possible material possibility is contained within issues 2 and 3. Either, therefore, the universe has no cause, in which case you're an Eastern mystic, the conversation ends, and it's not scientific. Or, the universe does have a cause, but it must be immaterial. Now, listen carefully, small fry, because you might hear some of these being given by people. What kind of choices do we have? Fairies, leprechauns, gnomes. The latest, of course, is the flying spaghetti monster. Awesome. The one that makes more sense, of course, to me, God. And you choose another. Only God even has any testimonies. So, if somebody tells me that my theory is no better than that of a flying spaghetti monster, I'll turn to that individual and I'll say, I don't believe in a flying spaghetti monster. You do! And I never get an argument at that point. The creationists are not the ones who believe in the flying spaghetti monster. It's the evolutionists who are. That's what I claim. But I'm an empiricist. You show me otherwise and we can start talking. I can rearrange those cosmological argument blocks into a waterfall chart as well. Does the universe exist? Issue 1. No, you belong in an insane asylum? Yes. We'll assume yes. Does the universe have a cause? No, that's unscientific. Yes. We'll assume yes. Is the cause material or immaterial? We'll assume a material cause and show a probable contradiction. From issue 2, did the universe always exist? If it did, it violates the second law of thermodynamics. We'll assume no. Issue 3, did the universe cause itself to exist? Yes means we have a violation of logic. No, the cause must be immaterial. And then we can go back to the immaterial choices that we saw earlier. This is powerful stuff, because the people who know what this stuff means realize that we have what we call a mutually disjoint decomposition of the space in mathematical terms. Meaning, there are no other choices available. These are the only ones. There never will be any others. So if somebody wants to come along and say, I don't know, maybe science will answer it later, I'll say, fine. I'll wait, and wait, and wait, and see what happens then. 2 can play that game. Issue 4. How can the universe avoid heat death? Heat death is what? Anybody know what heat death is?
All the same temperature.
Yeah, room temperature. That's right, like they say in the mobster movies. They made it look like an accident. According to thermodynamics, the universe can't avoid heat death. That's a consequence of the second law of thermodynamics. Le Chatelier's principle, which you might recognize from your chemistry classes, guarantees that any process that begins to occur from a disturbance of equilibrium will continue to completion until the system is back at equilibrium. Well, equilibrium in this case would mean there's no useful energy left. The universe will then be completely, forever deteriorated afterward. Is there any hope for a constant or steady state universe? I've seen some discussion about that point lately. But as we saw before, the new science better agree with the old science, and the old science says the thermodynamics are still there. They still have to be accounted for. Whatever other thing you might bring to the table, the thermodynamics still have to be accounted for. It's another case where the verified scientific laws don't displace other verified scientific laws. Your newfangled scientific law, it better not have anything to do with displacing thermodynamics, which, by the way, is so well established they haven't given any doctorates in the subject area for all intents and purposes since when? The 1940s. No other science is as well established. Issue 5, how can any material travel faster than the speed of light? Well, maybe you thought that none could. We don't have any actual observation to show such behavior. However, those who had evolved themselves in a Big Bang require a sudden hyperinflation at about 10 to the minus 31 seconds. I would ask a person making that claim, how do you know? Were you there? Do you have any devices that can measure time that small? I haven't heard of any. And I've also seen other people disagree with it and say 10 to the minus 35 seconds. Why would this hypothesis be around? Well, there's this problem about the universe, that is the cold, dark outside, being already stationary everywhere at 2.7 degrees Kelvin. Not enough time for it to have traveled from one side to the other if we have only 13.7 billion years. Well, I'm going to also ask, how do you know it isn't 10 to the minus 32 or 10 to the minus 30 seconds? And more importantly, why only at one time? Nobody's positing any time other than that. There's also a problem I haven't mentioned here. It's called the graceful exit problem. That is, once it begins to hyperinflate, what is the cause or the source of being able to bring the hyperinflation back down to the regular inflation? I don't know of anybody positing that. There was a news article on the 17th of March of this year that claimed to have evidence in favor of this. I also understand that those sorts of claims have been made in the past, even in the recent past, and they have fallen short. Well, I'm going to be an empiricist and say, we'll see. I won't turn my back or not look at the issue, but I would want to see what happens when the full scientific community looks at this matter in an unbiased way. I asked Hugh Ross's reasons to believe about this issue. They have no answer. Unfortunately, I didn't get to talk to Hugh himself, but the staff has no answer. Nor do they have an answer to this next issue, number 6. What is the origin, transportation, and distribution of carbon? I'd like some help from the audience. This picture shows what examples of carbon can we see or not see? One answer at a time, please. Who can tell me one example?
Diamonds.
The diamond. Okay, what else?
Coal.
The coal, that lump of coal. What else?
Living beings.
I don't know about the oil, but it would be an example. Living beings, such as,
Us.
is that in the picture?
No, grass.
Yeah, somebody said it was,
Fertilizer?
no, lots of other good guesses, right. A chia pet. Chia. Okay, are there any other examples? Notice I said see or not see.
Oh, not see. Probably carbon dioxide.
Very good. Carbon dioxide. What else? I've given this talk 4 other times and nobody has yet to give me another answer. Well, it would turn into nitrogen then, but I'm talking about carbon itself.
C14?
Well, it's the same thing as what she was, when it decays. Actually, the carbon-14 before it decays could be inside any of those other things, especially the living things. It's already there.
CO.
Carbon monoxide, very good. What else? Anything else?
Sugar molecules in the grass?
Yeah, anything that's in the grass will count as one unit. Anything else? Huh?
What's in the rocks?
What's in the rocks? Well, if we could determine what's in the rocks.
I think basically anything organic, right?
Anything organic. For example, we have plenty of this around here. Methane.
Yeah.
That's a gas.
Yeah.
Also, you could count if they're volatile enough. Carbon tetrachloride, carbon tetrafluoride, anything that has carbon in it. My question is, how do we get the carbon in the first place? That supposedly was solved in the 1940s and was awarded a Nobel Prize for, as you see near the bottom, the triple alpha process. The evolution cruncher, though it doesn't present things as well as it could, happens to mention that there are two barriers to getting to carbon if you try to have an accretion of one atomic unit at a time. And they are at molecular weight 5 and 8. The triple alpha process was posited to try to get over this barrier. What does it amount to? It amounts to taking two helium atoms, which came from hydrogen, which came from a star. We'll get to the matter of stars next. Two of these helium atoms came together, and before they could fall apart, in 10 to the minus 15 seconds, a third one came along to form atomic weight 12, which we know to be carbon. It can only take place at one nuclear resonance, only in red giant stars, and can be disseminated only by a supernova. In other words, the process is extremely improbable. Not impossible, but improbable. Where's the nearest red giant star now to the Earth? Anybody have any idea? Take any guesses how many light years away? How many? No takers? Minimum of 33, maybe as many as 40. Our sun does not qualify. It's not big enough. It hasn't been big enough yet. It never will be big enough, even when it reaches the stage, to have a supernova. It must be a star that large. What about a red giant star in the known volume of the solar system now? Well, first of all, I would ask the person making this claim, how do you know? I keep coming back to this question. How do you know? Well, let's see the evidence for it. But even if you have the evidence, I ask you another question. If the only way to disseminate it is a supernova, wouldn't that blow everything out in all directions anyway? I mean, supernovas will not jet everything in one direction to the Earth, such that we will have miles deep, thousands of miles long, solid coal beds several places throughout the Earth. I've asked further questions about this matter, and I'm getting answers like, well, things that are living die and decay and decompose, compactify, and we get our solid coal beds from that. And that apparently is the position of both the evolutionists and the creationists. Tentatively, I disagree with them both, because the coal is not uniformly distributed throughout the Earth. It's instead in big clumps. The evolutionist has a further problem. He has to explain, how did the life get here in the first place? That's another topic to be covered later also. But I would ask, how do we get those miles deep, thousands of miles long, anthracite, besides bituminous solid coal beds? Well, I don't think that there is a viable explanation yet. But if you have one and you have the evidence for it, that that's the way things actually occurred, come forth with it. Issue 7. How do any stars exist? Let's assume that we have a Big Bang scenario where all the mass is confined to an infinitesimal volume. That is a volume that's arbitrarily small, but not equal to 0. If we have a Big Bang, what will happen to the particles according to Newton's first law? Can anybody tell me what Newton's first law is?
They keep going until they come to rest.
That's right, you're reading ahead. What? What does it say?
Similar forces act on us.
Roughly speaking, something that is in motion will tend to stay in motion, and something that is at rest will tend to stay at rest. And that's why if something ever gets into motion, that it will keep going and going and going and never stop going. We have a hard enough time trying to compress gases as it is. That's the only viable means, supposedly, of getting a star in the first place, is to compress the gases. If I give you gases, right here, we have plenty in the air as it is. If you try to compress them, by whatever means you have, you'll only be able to do so within a small volume, not the volume of even a small star. In other words, there shouldn't be any stars. And there's a flip side. If I give you a generous 20 billion stars, years rather, there are supposedly 10 to the 21st stars in the universe. That would be an average of 50 billion stars per year, every year. Did you see your local newspaper issue any reports inside of your lifetime that said, we've made our 50 billion stars quota for this year? I see something else entirely. I see that we would be amazed to see one star being formed from those pillars that you might have seen back earlier in the slideshow. Issue 8, how do moons form? Let's even assume we have stars and orbiting planets around them. I ask you a silly question. How do you get solid moons from gaseous planets by blasting the planets? Well, I would say that's nearly impossible. But not absolutely. I mean, they're there. Some people posit that there is a nebular hypothesis. What is that? That everything was forming at about the same time. Well then, why are the planets gaseous and the moons solid if they're made out of the same material? But we have our own moon too. The most likely scenarios are that there's an object, and I saw a PBS special on this in the last day or so. A large object collides with the Earth. What's the more likely thing to occur than anything else if a large object collides with the Earth? It's going to stay connected to the Earth because of gravity. But let's suppose that it's even going fast enough, and it's big enough, like maybe something the size of a moon. In that case, the particles will supposedly come out of the Earth, where? Maybe the Pacific Ocean region? Better not be blasting out an ocean, because we don't have an ocean on the moon. Very well, no ocean. It must also exceed Roche's limit, which is about 1 to 2% away from the Earth. If it does not exceed Roche's limit, that the tidal forces associated with Roche's limit will cause the particles to fall back to the Earth, and there goes your moon experiment. Must also have a tangential, that is, a perpendicular velocity imparted to it. From what source I know not, to cause it to go to orbit. It must also be in the Goldilocks region of velocities. It can't be going too fast to escape velocity, or else it'll just keep going and going and going out in the other direction, perhaps captured by the Earth on a coincidental orbit. Or it's not going fast enough to reach orbital velocity, in which case it'll also fall back to the Earth, Roche's limit or not. If there were such a collision with the Earth, what is most likely to occur? The particles would have to come straight out. If they go in any other direction, then they have farther to go to escape Roche's limit, or in other words, to get into an orbital velocity. If they're going straight out, and they are kept that way, how often would they be orbiting the Earth if they ever got together and compactify, which is another problem too? How often would they be going around the Earth then? Well, the solid Earth. How often? Once a day. It would be geosynchronous with the Earth. what does our moon really exhibit as a property of how often it orbits the Earth? How often? How often? Yeah. In other words, once a month. So we got our name month. Once a month. In other words, the moon orbits the Earth not as is predicted by blasting the Earth. Also, not only do we have this quote from Wikipedia that since tidal forces overwhelm the gravity that might hold the satellite together within the Roche limit, no large satellite can gravitationally coalesce out of smaller particles within that limit. Take that, NASA.
Excuse me.
Yes?
Can you explain Roche's limit? What is that?
Roche limit is a distance out from a given body. It varies according to the composition and size of the body, whereupon tidal forces, the same ones that we speak of as out in the ocean, tidal forces overwhelm the particles, and they cannot stick together. Instead, they come apart. In fact, it's even theorized that when our moon is going to come back, recede back to us, that it will in fact break up once it comes within the Roche limit. This is true of any body that is held together only by gravity. We don't fall apart because we're held together electrically. We're not primarily held together gravitationally. Also, I want to mention something else. There is such a thing as the capture theory. I have a slide on this in a moment, but it's regarded as being too coincidental by most scientists now. However, for those people who still hold to a capture theory, I have another question. Why is there no evidence of other tribes? That is, other large bodies attempting to be captured. We don't see any evidence of this to the best of my knowledge. We have a hard enough time if we see a meteorite coming in our direction. Think of some events that occurred last year. Think of what would happen if you saw a moon coming in your direction. This is a busy slide, so I'll read it to you. Regarding the capture theory, since there was a considerable amount of discussion on this in one of my previous talks, this hypothesis states that the moon was captured by the Earth. This hypothesis was popular until the 1980s. ... A close encounter with Earth would typically result in either collision or altered trajectories, which is some of what I've been saying. The next red part, in addition, this hypothesis has difficulty explaining the essential identical oxygen isotope ratios of the two worlds. This is from Wikipedia, who favors the impact theory that I mentioned earlier. Issue 9. What is the ongoing source of comets? There are two kinds of comets, short-term and long-term. Short-term comets like Halley's Comet have a period of less than or equal to 200 years. They can be explained by the Kuiper belt of the interplanetary disk. Then there are the long-term comets, which are bigger than 200 years in period. Some of them could come from the same sources as the short-term. The rest of them, the Oort cloud was hypothesized. What, may you ask, is an Oort cloud? It's like an automatic pitcher of dirty snowballs. Conveniently, of course, to make up for the comets that lose their mass in the sun or otherwise. It would have to be way beyond our solar system, at least the center of it would have to be. I understand it's dispersed, and there's no actual evidence yet for an Oort cloud. There were a lot of people in one of the previous talks who argued vociferously that there is enough evidence that we can conclude that that's the case. I'm not convinced, and I don't think you should be either until you see more evidence than what has been presented yet. And there is no other hypothesis that's even offered. Issue 10. How do any elements heavier than iron exist? That's a little small to read, but that's the periodic table. You might recognize hydrogen in the left corner and helium in the right and so forth. You might see carbon along the second row. That was the one I was discussing earlier. And down in the fourth row, near the middle of the yellow section, do you see where it says 26 and it says Fe for iron, ferrous, ferric? You see that? That's what I want to focus on right now. In my modern physics textbook, I saw a curve that looked like this. There is increased stability as we move higher and higher towards this average binding energy per nucleon curve. What occupies the most stable position according to this chart?
Iron.
That's right. Everything else is less favored to form than iron is. So if we're getting heavier and heavier and heavier, it's counteracting the effects of the stability of the average binding energy per nucleon curve. What's the assumed method then? A supernova. What is a supernova going to do though? It's going to blow out everything in every direction just like it did carbon. How is that going to explain the transportation and distribution of those elements? And how is it that we're going to see anything, cobalt, nickel, copper, zinc, all the way up to uranium, element 92, how are we going to see any of them in any economically mineable forms from the Earth? I don't know of any, but you scientists out there, you geologists out there, come up with a decent explanation. And one that is in accord with known scientific laws that we understand today, not ones that are promised into the future. Issue 11, how do peptide bonds exist, or how do they form? I need some help with somebody here. I need somebody else to hold the mic. Anybody, you. Go ahead. And you're going to travel with me. All right? You're going to hold the mic and you're going to travel with me. I have in my hands models of, not that close, models of amino acids. I'll talk about the fact that one of them's left and one of them's right in the next presentation. I'm going to walk this way. Thank you. All right. This is a representation of an amino acid. The middle carbon atom, which you see in black. You see that middle carbon atom right there? This small thing is a hydrogen. This is a functional group in red. It can be either hydrogen or any of 19 other functional groups. This is representing a nitrogen with two hydrogens, called an amine group. Are you familiar with ammonia? That's nitrogen with three hydrogens around it. In other words, it's a base. On the other side, a carbon doubly bonded to an oxygen atom and also bonded to another oxygen, which is in turn bonded to another hydrogen. This group is called a carboxylic acid group. Can everybody see those? Everybody see those groups? This is a representation of an amino acid. And how they form together? NHCHCO. NHCHCO. I'm going to sit down for a moment. Have you heard that hypothesis that said that we came from a warm little pond? Just how is that going to occur when a water molecule must drop out rather than be absorbed by the amino acids? This is a problem. Okay, so we don't have a warm little pond. I can think of a few other problems though. If it's not in a pond, then that means it's exposed to the air. What kind of air is it? Is it oxidizing or is it reducing? If it's oxidizing, meaning we have oxygen in the air, then the oxygen will break apart the bonds, maybe even destroy the amino acids themselves. If, however, we have a reducing atmosphere, then we don't have any ozone, in which case the UV rays come in and they destroy the amino acids or their bonds. Everything had to be in place. There has to be a body which has all the chemicals inside and wicks away the water that would otherwise destroy the amino acid formation into peptide bonds. In other words, we have a chicken and egg problem. Which came first, the chicken or its egg? God. But of the two, a hen and a rooster came first. It wasn't Adam and Steve Rooster. It wasn't even Guinevere Hen. It was Adam and Eve Chicken. If we have no peptide bonds, we do not have proteins, we don't have enzymes, we don't have life. Without biochemistry, it's Amino world. Issue 12, how do proteins have only amino acids? These are representations of left-handed and right-handed amino acids. They form a mirror image. You can see the mirror image in the screenshot, where the carbon is in the middle, the carboxylic acid is up in the top, the amine group is over on this side on the corners, the hydrogen is at the top, and the functional group R is in the lower corner. They form a mirror image. Notice that these two on the top are the same, but I've reversed the positions of these two. That's the best you could do. You can't stick one on top of the other and have them match atom for atom. That's not possible because of the spatial relationship of the molecules. Let's take a little walk. Can everybody see the fact that these don't match? They don't stick on top of each other? You can get two of them to match, but not the others. Therefore, these are actually different molecules. Thank you. They have the same melting point, boiling point, refractive index, vapor pressure, chemical reactivity. All the environmental properties are the same. The only thing that happens that makes them different from each other is that the left hand will rotate plane polarized light by so many degrees in one direction, and the other by the same number of degrees in the other direction. When I heard about this problem between my first and second day in biochemistry, reading this textbook on page 14, I immediately saw that this was going to be a problem for an evolutionist. If we start off with neutral ingredients, neutral environment, neutral energy source, what should we expect to see? Equal amounts of each. What do we actually see? Every amino acid and every protein of every species is only left-handed. There are no right-handed ones. Isaac Asimov offered no explanation whatsoever. He just said, it happened that way. If he were still living, I would have asked him, everywhere across the face of the entire globe, there are right-handed or dextrorotatory D amino acids in other structures. For example, bacterial cell walls. Otherwise, the enzymes, which are all left-handed, would break down the cell walls. You probably wouldn't be left alive either because you need bacteria in your intestine. There are other names that we also give to these compounds. Stereoisomers, enantiomers, chiral compounds, mirror image compounds that are non-superimposable. I'd like to read something from memory in this organic chemistry textbook. As to the origin of these optically active compounds, we can only speculate. The situation is no better now than when that book was being written in 1972. And it was known for more than 100 years before that. This is a cube with the tetrahedra embedded into it. Two tetrahedra can be embedded into one cube. I don't think it's any accident. I think this is a property of design. The two of the Platonic solids, there are only 5 of them, should have this relationship. One is embedded in the other. Not only that, but any high school student should be able to figure out the bond angle. Say, for example, I take this red one, this central black one, and this red one over here. There are any number of others as well. What's the bond angle of that? You can use the law of cosines from ordinary Euclidean geometry and calculate that it must be equal to the arc cosine of -1/3, which to the nearest seconds is 109 degrees, 28 minutes, 16 seconds. That'll be good for things that have an equal entries on each of the 4, like say all the red ones. For example, we mentioned earlier methane, carbon tetrachloride, carbon tetrafluoride. In the case of amino acids, since the only thing that differs between them is the functional group, we have another cue and clue as to what kind of functional group we have by the stretching or the retracting of that functional group, and that will give us a clue by reason of measuring the angles. Somebody's also likely to ask, well, can we mix left-handed and right hands together? It's not as favored, but there's no reason why we couldn't have an all right-handed chain, except that we don't have any, at least for proteins. And in case anybody is asking whether or not I'm just throwing out a bunch of models and a bunch of formulas and so forth, that is a copy right there of the Phi Lambda Upsilon register. I'm a member of this honorary chemistry fraternity. I wear that badge proudly despite mostly being a mathematician. Issue 13, what turned non-life into life? Suppose I just give you a dead dog. Assume it's dead long enough, 3-4 days, whatever. One small task, Hercules, breathe life into the dog. I've given you everything. Brain, heart, lungs, liver, spleen, spinal column, stomach, nervous system. I've given it all to you. What's the matter, Hercules? Isn't this a small task? Aren't you Hercules? Well, maybe the problem is much bigger after all. Now, I ask you a silly question. If we can't breathe life into a dead dog, what makes you think that we can breathe life into materials made into a dead dog? And you have a lot farther to go if all you have to start with is hydrogen. Or worse, an infinitesimal. There is no spontaneous generation. There is no Goldschmidt hopeful monster. And no scenarios about RNA doing all the work. That's just a theory right now. Life only comes from life. That's all we've ever known. Pasteur showed it in the 1860s, and it's been shown by everybody else since then with no examples to the contrary. Issue 14, how does metamorphosis occur? There are at least two different kinds. One is amphibians, and the other is for insects. I'm going to take one issue from the insect world. I might give you, in the 4 stages, egg, larva, pupa, and adult. An adult laying eggs. The eggs hatching into larva, and the larva turning into pupa. But would somebody please explain to me how that pupa in its mushy state, with no control over its own destiny, turns into an adult? I don't have any answers for that. But you biologists out there, come forth. I'd like to see some answers. I really do. I'm not being disdainful. In the meantime, it does not suffice to say, we don't know. We're just going to wait for science to answer the question. Very well, as I said earlier, I'll wait. And wait. And wait. Or we could go into the lab and do a bunch of measurements. We'll take those measurements. We'll do them as long as it's necessary, as long as we're alive to take those measurements. Ignorance is no answer. If you say you have no answer, just plead your ignorance. Issue 15, how do major morphological changes occur? What are morphological changes anyway? It's kind of a redundant term. It's meant to say, how does one thing change into another? Specifically, fish to amphibians, amphibians to reptiles, reptiles to birds, and birds to mammals. Maybe you've heard of some of those transitions supposedly being possible. I would suggest that a lot more work needs to be done in order to see that through to reality. For example, in the case of going from a fish to an amphibian, how is it that we can go from no metamorphosis to metamorphosis? How can we go from a 2-chambered heart to a 3-chambered heart? From an amphibian to a reptile, we go back to no metamorphosis, and we go from external to internal fertilization. From reptile to bird, we go from cold-blooded to warm-blooded. I'd really like to see that one. And from scales to feathers. And from bird to mammal, how can wings go to paws, hands and hooves, and feathers to hair? And you have to have them true of both male and female, essentially co-located to form a colony. Not two on other sides of the earth, or as was said in a famous song years ago, the other side of the mountain. Not going to work. 16th and last topic. What creates information from gibberish? Communication requires a sender tuned to the receiver, a receiver tuned to the sender, and a medium to promote rather than interfere. For these kinds of subjects, we'll employ what is called the autocorrelation function. That's a measure of a sequence against itself. Suppose I have a bunch of numbers in a row. Say the numbers 1 through 10 in order. It's going to be highly unlikely that that particular sequence would form all on its own. I have to be careful what I say in regard to this. If, however, we jumble them up into some configuration that doesn't look anything like that, like 1, 3, 4, 8, 2, 7, 6, 5, 10, 9, any such thing, like monkeys typing letters on a keyboard, that's more likely to show up as random. An autocorrelation function, which we can find in books like this, which is Radar Handbook by Marileigh Skolnick, is the editor, has discussions about things like this. And also the grand generalization known as an ambiguity function, which measures range and velocity. If you want to bury a code, you do work in things like this. We mentioned earlier that there's such a thing as entropy. We were speaking of an energy entropy. There is a corresponding concept known as information entropy, where information becomes scattered like the monkeys and the keyboards. All life structures need information. We need DNA to code for proteins and proteins for DNA. Another chicken and egg problem. How are you going to get from one to the other and the other to the one when you've only got one at most anyway? In effect, we are brought back to topic number 1. Existence. This is information too. In fact, it's about the most, or the least biased example I can think of next to the dictionary. So we're brought back full circle. I'd like to pose something else. 16 modern scientists. Do you recognize any or all those names by any chance? I hope so, because they are located in your modern mathematics, physics, and chemistry textbooks. Tell me, what else did they have in common?
They believe in God.
They weren't evolutionists. Some scientists back in those days were evolutionists, but not too many. These are the references that I used implicitly or explicitly. Only the ones in green are not secular references. All the others are. I'd like to give some credit. Joe Emilio had most of the slides. Tom Canfield in the back also contributed, as did Navy SEAL Chad Williams. There's our end. I'd like to break for bring up Q&A later.
Okay, does anyone have a question?
Yes, sir.
Okay, how much carbon is there can we see in other stars by the spectrum? Can we see carbon anywhere else? How much carbon can we see outside of our solar?
I don't know how much. I don't know how much anything could be seen. We could leave it to the people who operate the spectrographs. But there's not really a doubt as that we can see the elements by reason of their emissions. My problem here is not whether the elements exist. My problem is, how did they get there? How were they formed in the first place? And how are they disseminated once they were formed? So the common solution to everything, it seems, is a supernova. I don't find that to be credible at first glance, at least, because A, if you're going to try to form things by a supernova, that's not bringing things together where they need to, which is what you'd have to have in order to have a continual accretion of molecular weight, or atomic weight, really. And the other problem is, of course, this problem of distribution. Things are not mineable. They're not economically viable anywhere. And we know that they are economically viable on the Earth in places. Like, for example, most of the precious metals, the diamonds and so forth, occur in 2 places, South Africa and Russia. 98% of them, I understand. It's not scattered all over the Earth. And if it were scattered all over the Earth, it would not be economically mineable. So that's about the best answer I can give. Any other questions in any regard?
This
Yes.
hyper-expansionism,
I call it hyperinflation, some people just call it inflation, yes.
the idea is if it was hyperinflating, it would continue to hyperinflate. Why would it stop?
That's the graceful exit problem that I mentioned earlier. Nobody has an answer to the graceful exit problem, the best I know. Nobody would understand why, why if it started, why it wouldn't just, or why it would have to then fall off. Yes?
I was just going to mention that the original Big Bang theory had problems with the evidence. The evidence didn't fit it, so they had to invent something. So some guy came up and invented the inflation theory to get rid of some problems that the evidence.
It's mostly the what we call the anisotropic nature of the background temperature of 2.7 degrees Kelvin.
Well,
it's already there.
No, I'm saying that the Big Bang theory, there was lots of problems with it.
That's certainly, but that's the big one.
Not the temperature.
We can agree to disagree on that one. I think the temperature is a big part of it. Yes. Any other questions? Yes.
Well, I just know that there's several Big Bang theories.
Mm-hmm.
So when he says the Big Bang theory, which Big Bang theory is he talking about?
Yeah, that's true. I was there's only so much, of course, you can do in a talk, but I was covering that aspect which is most commonly accepted, if you want to call it that. There are certainly other variations on the theme. One could cover them individually if you like. We could have a whole session on Big Bang cosmology if you like. But I was just trying to say that there are crass or gross problems with the one that's most commonly accepted. And we can. These are really just sketches. Sure. I don't doubt that for a moment. Another one. Back here. Yes.
Quick question.
Yes.
So wait, you said the diamonds primarily come from Russia and South Africa or South America?
South Africa.
Most of the diamonds are found in South Africa and Russia.
Okay. South Africa.
I understand it's about 98%. Whatever it is, it's a large amount.
Mm.
And same goes for a lot of the precious materials too.
Mm.
You should be keeping track of titanium, which is used for airplanes.
Mm.
No titanium, no airplanes.
Oh yeah.
Flakes off and you can't use it again. This is part of the. I think it was the titanium problem that drew me most of the matter of the things are concentrated to become less so, rather than the other way around.
Mm.
Yeah. We have another question over on this side, I think. Yes.
I always think evolutionists is somebody who believes in Darwin's theory of evolution. So how are you referring to evolution as dealing with universe existing moons and all that? That's not Darwin's origin of theory.
Well, I started off very early in the talk by mentioning that there are many things that evolutionists see a stake in besides biological. That is, to have a complete explanation of origins. If there is some hole or something missing, then somebody else can enter the picture and say, and this is what they would never want to say, God did it. Now, I'm not going to say that as an empiricist, but that's what they would say. So they feel they must come up with an explanation for all these things that feed into the matter of biology later. Since biology is only what, at most from 4.5 billion years for an Earth that would supposedly be that old. What do you do with the remaining 9 billion years before it?
Well, what do you want me to say? 16 years possible atheists things.
No, I'm going for evolutionists in particular. Atheists they may or may not agree with such things. In fact, I even had a lab TA at the time who was an atheist that didn't believe in evolution. He does now, but he didn't then. He said so. He doesn't even remember what class I took from him either. I found that out when I called him last year. Any other questions? Yes?
Regarding comet formation, what problem is the Oort cloud because it has not been observed, or because it doesn't satisfactorily explain what's over my head?
I think, first of all, we'd have to have the evidence that there actually is one. That is solid enough to say, there's our Oort cloud, and it's the body responsible for producing those long-term comets that we haven't been able to explain otherwise. My understanding is that is still not settled in the sense of we can point to it and say, there it is. Now, some people have said there are indications, whatever they might be, of light not being able to penetrate as opposed to around it, or gravity, or whatever. They make for nice hypotheses, and I'll grant them they are hypotheses. Science really goes further than that to try to come up with an explanation. And what I would say is that so far the explanations lack rigor. I'm a mathematician by training, and I know what rigor is. Every last little piece has to come together and has to be accounted for. There can't be, as Columbo would say, little loose ends waiting to be tied up yet. And there are too many in my opinion. Okay? Any other questions? Yes?
Can you explain again the thing about the iron?
Sure. Let me go back to the slide, even if I could. The question I asked was, how do any elements heavier than iron exist? And what I pointed to was the average binding energy per nucleon curve. Iron is in the most stable position on the chart. And I phrased the statement precisely. All other elements are not as favored to form as iron is favored to form. It's not saying they can't form, it's that they're less favored to form. And it is a problem that's recognized. Otherwise, why would somebody come up with an explanation like a supernova for this, when it's got all the problems it does? Is there another issue on that I can answer for you?
I'm trying to get my head around.
Yeah,
I don't
it's,
quite understand.
this is as far as I know, no other creationist has ever discussed this issue. I could be mistaken, but as far as I know, that's true. I haven't heard anybody come forth and give me an explanation. I looked everywhere for this, too. I would have never known about this had I not been taking a modern physics class just about 8 months before I was taking that biochemistry class. There were a lot of things that came together in that 1 year. A lot of the topics that I mentioned are from information that I gathered in those last 2 years of school. That was one of them. Another question. Yes?
Actually, I'd like to share a few things, if you don't mind.
Sure.
One of them is evolutionists tend to be atheists. You know, science can answer everything, and we have all the answers, this sort of thing. I would say, ever heard of Albert Einstein? Oh yes, what do you think of him? Well, maybe the greatest scientist who ever lived. So, he's smarter than you are? Of course, many times. Well, he believed in God. Where does that leave you?
What sort of God he believed in is up for grabs, of course.
The other thing is, I think evolution to this day, referring to the theory of evolution. By definition, a theory is a concept that has some promise yet to be proven. If they really believed in it, they should drop the word theory, because theory means something of which there is evidence that indicated may or may not be true. We haven't really nailed it down yet.
Well, that's a subjective judgment as to what one would like to call it. Some others would just leave it at hypothesis. These are somewhat subjective terms as to what you want to call things, but in the scientific method, of course, the more evidence it has, the more probable we believe it to be. My problem is that a lot of these things are cast about even though they have very little of any evidence to support them, or they contradict known scientific laws, which is my real problem.
From my understanding of Darwin, too, I think it's very credible the way he proved that, not evolution, but that birds' beaks would change with time depending upon what they were feeding on. Slight genetic adaptations, if you will, survival of the fittest, if you will. I think that's credible, and I think it can be proven, I think it makes sense. But it's a gigantic leap to say a bird eventually can form a different kind of beak or a different kind of wing or a different kind of claw than to say a bird can become a pig or an elephant or whatever else they think something can evolve into something else. Last but not least, if you don't mind.
Just one I would refer
What little I know about the Big Bang Theory, which supposedly created everything, is I've heard it was the size of a softball. I heard it was a hard ball. The other day on TV, I heard it was about the size of your fingernail. The universe was created for something the size of smaller than a softball. That to me takes a giant, giant leap of faith, something they knock the rest of us for having.
Well, the first question one has to ask at that point is, what was the cause for it to not be left in the state of being an infinitesimal? What would have caused it and why at that particular moment in time at all? I don't know of anybody coming up with any answers, Ellen Guth or otherwise, for that. But while those are also valid questions, the reason I chose the topics I did was mostly because I could show the contradiction between the answers being given and known scientific laws. Whereas the others, it's harder for me to posit one against the other. It's harder to show a contradiction rather than what I chose. Those things, every one of these things that I chose has an outright contradiction. So, any other questions? Yes?
I had a comment on
Sure.
the cosmos theory, which is a remake of the Carl Sagan's theory, and he says evolution is not a theory, it's a fact as much as gravity.
Well, I would say evolution is an opinion in that case. Anybody who wants to say such things as settled science and so forth doesn't know the meaning of science, really, because science is never settled. Whatever your position is otherwise. Science is, if we define it by empiricism, is always subject to change, always subject to more facts, more knowledge, more everything. Let me never be an impediment to that. And if a whole theory should be overturned because that is what the evidence leads to, so be it. Any other questions, comments, suggestions? Any? Yes?
Last question for me. Did you ever read anything of Dr. A.E. Wilder-Smith and his treatment of the left-handed molecule?
Oh, I know people have mentioned much in favor of him. I wasn't as impressed, but what say you?
Well, that's where I heard it. I read the natural sciences know nothing of evolution, and he treated the right-handed, left-handed molecule. That's all I know.
Well, he wouldn't be the first one. I came across the left and right-handed all on my own, a little later than I should have, as it turns out. It was only connection with the amino acids that finally dawned on me that there was going to be a problem, whereas in fact, my organic chemistry textbook, from which I was citing as to the origin of optically active enzymes or optically active compounds, we can only speculate, came straight from my organic chemistry textbook, and I should have read it better at that point. And then it would have made a lot more sense earlier than it did. But at least I finally found out, and finally it came to me. Maybe it just took some maturity, too. Any things, all sorts of things can happen when you're only 20 instead of 23, right? Okay. All right. Any other questions? Yes?
Well, the idea of species, evolution within species, we allow for variation of kinds, but just not evolving from one species into another species, like a cat into a dog, or a bird into or a snake into a bird. That's what I think most of us have problems with, saying evolutionists have absolutely nothing to stand on with that. But there is variations, and that I'm sure God put in the gene pool all of these things that, that when something needs to be changed, it can be changed. It'll be changed.
It's trickier to argue at the lower levels. You might recall kingdom, phylum, class, order, family, genus, species as being the gradations. The reason it's harder to argue at the lower levels is because there are several different taxonomies. I understand that in one case, a male and a female of one species actually end up being in different families in a different taxonomy. Things get interesting with worms, sponges, jellyfish, and the like. It's not clear how to classify them in the lower levels. However, there does not seem to be any argument regarding kingdom, phylum, class, and order. So between order and family is where the dividing line normally is. And by the way, Evan Schuden in Flaws of the Theory of Evolution, I believe, makes that point very well. So the only way of really testing whether or not anything could have come from anything else is to back cross to see what becomes of things. That is, take something that was supposedly future and back cross it with something that came in the past, and do they provide or produce viable offspring? And even that isn't really proof. It's only really a negative test. But, anything else? Any other questions, comments, suggestions? Anything else? Going once.
The capture theory of the moon, doesn't it seem that some asteroids have captured their little orbiting moons around them?
Well, if there's sufficient gravity, I suppose. I'm trying to figure out what how that plays into this talk. But anything else? Well, if not, you can ask me afterwards. Thank you very much.
Thank you.